It's pretty straightforward. By the way, I'll be sending a exam review. I forgot. I think it was Unit B or Unit C. I have not had a chance, but I did post it in the review so you can practice it. And so all the due dates are on there. Also, the first exam is completely graded, so I'll be grading the second one as soon as I think it's closed already. I need to check, but if it's already closed, I'll be doing it probably tomorrow, if not this weekend. But anyway, let's get started. Okay. Annotation. Whenever you see this f plus g of whatever here, all that means is you add the functions and plug in -5. So just real quick, a quick note. F plus g of any value x is equal to f of x plus g of x. That's all they want you to do. So for this example, f plus g of -5 is equal to f of -5 plus g of -5. Just plug it in. Here is my f and g. So plug in -5, so that will be, put parentheses for emphasis, -5 plus 3 plus -5 squared minus 2. So this is my g right there and my f. So this is just -5 plus 3, so that's a -2. -25 squared is, -5 squared is 25 minus 2. You guys agree that we get 23 here. Okay. So our answer will simply be 21, right? Well, that's all this means, this notation. Same thing for this guy, the minus, it's just a minus version. So if you see f minus g of x, the formula basically tells you that this is same. Add the f and, or sorry, subtract the f and g. Those same functions, just plug in 3 and then subtract. Okay. F minus g at 3 means plug into 3 and subtract them. So 3 plus 3. Plug in 3. So that'll be 6. Oh, I made a mistake. We're subtracting the entire g function. But that needs to be in parentheses. So 9 minus 2 is 7, so it'll be minus 7. But essentially, that's how it starts off. Just understand what these mean. If you see it times, we'll multiply them instead. See division, do the same thing. Is there any questions on the adding, subtracting, or etc. for functions? Is it doable? Okay, let's move on to something else. All right, so you can see 3 and 4 are just times, so I'm gonna move on to something else here. Here, they're just doing it in general. But there is a notation that you should know. When they start, the domain and range part is the hard part for these questions. So all you need to know, at least for these type, the domain will be simply the intersection. So the domain for all, hold on. Ones for these are exactly the same. So if A, let's call it the sets A, B are the domains of F and G, then the domains of A through B on these questions, but really in general, just for any of these type. I'm sorry, A through C. Is A intersected with B. So another section for D, let's see, let me think how to phrase that. D is almost the same, you just can't divide by 0. Okay, so for D, we'll call this the first one. Second one, double star. For D, the domain is A intersect B, except G cannot be zero. So any x values that make G zero, it's not in the domain. So basically find the domain of each of these two, and then figure out what they have in common, and if they have everything in common, well, that's the domain. This one, you have to rule out that division part. Can you hear me okay, Steven? Sorry, I just saw that. Okay. Let's see. Okay. They didn't ask the domains for A through C, but they did ask for D. But if they did, this is how you would find them. Just figure out what makes the bottom zero. So you, for F over G, you agree that this would simply be this, right? They can plug in any number except 2. The domain is everything except 2. So in integral notation, though, you would write negative infinity until 2, and then everything after 2. Any questions on? I didn't do A through C because they're just adding them together, but I want to do the hard part. Do you have any questions on the domain or part D? Does that make sense? Do you have any questions on A, B, or C? If I can, we can discuss it if it's not clear. Okay. So 6 is the same deal. Eight is a little more interesting. This one will be a little harder, but very similar. Because if you notice, 5, 6, 7, their domains are all real numbers. But 8, F is all real numbers, but G has a restriction where the inside must stay positive. So you'll have to find that domain first, and then figure out what they have in common, and that would dictate the domain for all of them. But they didn't ask, so you just need to focus on D and divide them, and then determine the restriction of the denominator and the restriction of the radical. So let's do part D on number 8 before we move on. So you can see what I'm saying. Oops, forgot the. Okay. So the domain for D. First of all, the function is going to be this. So what is the domain for G? Well, how would you find it if you don't see it?
Set it equal to 0.
Close. What does the insight have to be? Has to be positive. So you just say, you know what, I want this to be greater than and or equal to 0. Solve for x, and you will know what the domain is, because that satisfies the restriction for square roots, or actually any even root, square, fourth, sixth, eighth root. The inside must remain positive, but it can also still be 0. So add, subtract the 6 over. Oops. Divide by -1. When you divide by negative, the inequality rule says you need to swap it. Okay. So as long as the x that you choose is below -6 or equal to, then it'll stay positive inside. Let's say 0 or less, or positive, sorry. So the domain would be oops.
I have a question. The first step when you subtract the 6 from the left side, wouldn't it be a -6?
Oh yeah, you're right. So this would be minus, and this would be plus. Yeah, there we go. Let me fix that. Okay. So the only issue, right, is we said now that's in the denominator, it can't be 0. But G did allow for 0, right? So G includes 6. F over G cannot include 6. Does that make sense? So this right here is domain. I'll put it down here. What did change it to satisfy D? Okay, so it's from the top. To find the domain of A through D, you have to find out where these two, where the domain of F and G overlap, which just is going to end up being negative infinity to 6, right? D means you need to make sure that G is never 0. So the domain would have to be parentheses. Does that make sense how we find the domain of G? I'm sorry, F over G. Okay, so you guys are good. I'm gonna move on then. If it makes sense how to find the domain of F over G. All right, cool. Let's move on to something else. So here they are not giving us the functions, but they're giving us the graphs. So it's not too bad. So we'll do this one and then we'll talk about compositions. Remember that this means F of 3 minus G of 3. But look at the pictures. What is F of 3? Yeah, 2, right? Look at the graph. 3 is right here. So the function at 3 is right there. What is G of 3? The output is 1, so 2 minus 1. All in. F of G of 2 means F of 2 times G of 2. What is F of 2? Yeah, the output is 0 for the Y. Minus G of 2 doesn't really matter, but let's do it. Oops. Mistake. All right. Any questions on 9? Does 9 make sense? Fog and golf. This we need to talk about before we do it. See here. Okay. So composition, if you see f of g of x, this means plug in g inside the f. Okay. You see it the other way, we'll switch it. So for this example, this is saying f of g of 2. So what is g of 2? Right here, right? Yeah. So 2 will be here. Now what is f of 2? Yeah. 0. So we found the composition of f and g at 2 means you're inputting 2 at g, and that output is then going into the f. Okay. So just side note here. G of 2 is equal to 2. F of 2 is equal to 0. But fog at 2 is also 0. That makes sense, the composition. Like what the notation means. Plug in 2 into F, we said that that was 0. So now we have G of 0. What is G of 0? Yeah. So this is called composition of functions. Yeah, two functions are composed together to give an output. You guys cool on 10. All right. The hard part is find the domain for a composed function. The outputs and inputs aren't too bad, as you can see. Just follow this logic. You'll be good. I mean, there's a lot of real life composite functions. I mean, if you call, I don't know, let's say you had a function that created clean clothes, right? So you could have two functions composed together. The inner function would be washing clothes. Outer function would be drying clothes. Final output would be clean clothes, clean, dry clothes. So just doing combining one whole task into one. Or sorry, multiple tasks into one task is basically two functions, one function. Same deal. Here they want us to compose them in general and just give the actual function. Not too bad. So find fog. This means, again, means this, which means compose F and G. In other words, plug in the G into the F. G is x plus 7. F is -5. So that would be -5 times your input. That'd be -5x minus 35. So that is fog. The composed function would be minus 35. Does that logic make sense to you? I input x plus 7 into F. What does F do? Well, F multiplies whatever input times -5. So here we go. -5 times that input, which happens to be G, gives us this new composed function. Any questions on part A? I mean, if you get fractions that reduce, go ahead, but there's nothing here that combines. You see something that has more terms, yeah, do it. Make sure you get the simplest form. Okay, plug in f into g this time. So f is -5x. Okay. G is x plus 7. So what does G do? It adds 7 to any input. The input happens to be this plus 7. So our answer would be that guy. Any questions on part B? You can also compose a function with itself. So GOG. You plug in G inside G. It's weird, but and G is x plus 7, so you're gonna have x plus 7 going in as the input, and then the function adds 7. So there we go. Any questions on 11? Cool. So not too bad then, right? 12 is the same deal, just harder looking functions. The only thing that changes is the algebra. That's it. Ah, here we go. 15 is the stuff I was worried about. Cubics. Yeah, it's not a good question though. This guy kind of sucks. Nothing but easy ones. I thought there'd be a hard one in here. Okay, well, whatever. Okay. We'll just do this one, I guess. All right. So first find the compositions of Bog and Gov. So this guy means plug in G. Let's skip a few lines here or steps. So this x cubed plus 1 is going inside the cube root. So that will be x cubed plus 1 minus 3. X cubed minus 2, right? That's all we can do. G of F. So this will be G cube root well, that's it. G cubes it and then adds 1. Okay. So these cubes will cancel. Cubes, cube root cubed gives me this. So there's my two functions. Any questions on the algebra? Is that first 2 parts okay? Okay, so what is the domain of F? Can you, does odd roots have restrictions? Or do they have any restrictions? No. So the domain should be anything, everything's cool. All right. G, can you cube any number? Is there any restrictions on x cubed plus 1? You can, there's nothing, you graph it, it'll go on forever. I see no restriction on G. There's no reason why I couldn't cube something and then add plus 1. Now to find the domain for composites, you first have to find the domain of the one that's going in, the G, for fog. You see how fog has the G inside? So the one that went in, did it have any restrictions? Looks like no, right? It was x cubed plus 1. So the first thing you gotta ask yourself, the one that went in will create, if it has any restriction, will create restrictions on the composite. But if it didn't have any issues to begin with, then don't worry about it. Next thing you do is look at the result. Does the result have any restrictions? And we said cube root is fine with whatever. So then the composite should be the same, everything. That logic makes sense? Look at the resulting function and see if there's any new restrictions, like, I don't know, division by 0 or an even root or something. And then look at what you plugged in and see what restriction was on that. And then just combine all those restrictions into one domain. Okay. So when I said there's no hard one, I meant there was no function that had strange domains that would make finding this hard. Since they were both infinity, then the composite was pretty much the same, especially since the result was not a big deal. But if these functions were, like, let's say, I don't know, let's say this one was like square root x, and that was going inside here, inside the f. Now the fog, the resulting function, would have the restriction of this. And anything else that would appear after you plug it in would also be an additional restriction, which will dictate the domain for fog. But since there's no issues, it's not interesting, and we don't have to think that hard, which is a problem. But is there any questions on that idea? Okay. Now look at the domain for g of f. There's no restrictions here, so we don't have to worry about that. There's no restriction in the results, so again, we don't have to worry about that either. So the domain would be the same for g of f. So just check what's going in and what's the result, and then create an interval considering those two issues. If you have any, if you don't have any issues, then the domain is everything. Are there any questions on 15? Good. These will all be the same, it's just different functions. Fine, for 17, we kind of want you to create H on your own. What would be the f and g to create H? Which two functions would you give them to create what they gave us? So do you see how there's like an outer function and an inner function? So this is the inner, right? And we understand that the fog means this. So this is H. So what is the inner one? What does the inner one have to be to result in this? Yeah, the inner one has to be that 9x plus 8. And what are we doing to that 9x plus 8? for squaring it. So the outer one has to be a squaring function. Does that make sense? So if you were to compose f and g, you would get this, the h. If I plug in the 9x plus 8 inside x squared, will I get this? Is that clear? So they want you to understand the concept of visualizing the inner and outer functions of a composite. Any questions on 17? Let's stick for this section 2.6. If you look at the lectures, make sure you understand the domain and range for composites. The ones for the pluses and minuses are not that complex, so one second. All right, so inverse functions. Basically, well, the first thing, in order to have an inverse, it needs to pass the horizontal line test. So basically, it has like more restrictions than the function, the vertical line test. But the whole point of an inverse function is it undoes whatever a function does. So, for example, if your function just adds 2 to any number, then the inverse would subtract 2, right? If your function is a squaring function like x squared, then the inverse would be square root undoing squares. Not all functions are one-to-one, but you can restrict the domain and create the function based on a shorter spot. Like, for example, let's say I had these two functions. Can you guys see the graph here? Okay. You see how the red parabola would fail the horizontal line test? So I would have to restrict it and say, you know what, the red one is only defined after 0, so only the right half would be used. So if I restrict it, then I can define an inverse. So if you ignore the left side, you can see how the inverse would be the blue one. Okay. But in order to find it, in order for there to be an inverse, it has to be 1-to-1, or you got to force it to be 1-to-1. So is this function one-to-one? Would it pass the horizontal line test? So basically, the easy way to tell if it's not making sense, every input can have only one output. That's the function definition. But I believe the inverse would then be no input can go to the same output. So basically, every input has a unique pair. So there's no sharing values. Like how before we said a function can send all your inputs to the same place and it's still a function. For it to be one-to-one, the algorithm, everything needs to go to different places. Okay. And that's the easiest way to think about it. So do any of these share a y value? Does a y value repeat? And of course, all the x's don't repeat either, right? So it should be. Does this line, well, let's look at this one. Does this semicircle have an inverse?
Yes.
All right, so it has to pass, the first one needs to pass the vertical, right? So that's good, but it does not pass the horizontal. So if a function fails the horizontal line test, then it is not one-to-one, which means it cannot have an inverse. So it has to be one-to-one. So easy way to check is just draw horizontals, and you'll know for sure it does not have an inverse. I would have to restrict it, right? I'd have to restrict it from here to here or something to force it. I believe it's the beginning. The question's at the beginning. Yeah, here we go. The graphical test for the existence of an inverse function of f is the horizontal. Okay, does this guy have an inverse?
No,
Why not?
because the outputs repeat twice.
Yeah. So because there's two x's that share a y, this would fail the horizontal. So if you see the y repeat with different x's, then no. Okay. So here they want us to verify if these functions are inverses algebraically. So if you compose them together, they should completely cancel out, giving you an x. Let's do 12 because that's easier on my eyes. If everything cancels, then cool. If they don't, they have to cancel both directions. Fog and Goff have to both turn into x. If they don't, they are not inverses of each other. It looks like they are, but we got to check. Okay. So here he wants to do it in steps. So plug in G into F. So they already did that part for us, so just plug it in. So what would that be? Well, it's gonna look weird if I do it there, so that means you cube it, cube the input, which would give me, these would cancel, giving me x minus 6 plus 6, which would be x. So if I end up with just an x, that looks like it might be an inverse. But it has to work both directions. Now do it the other way. This means g of x cubed plus 6. So that would be cube root of x cubed plus 6 minus 6. It would become cube root of x cubed to cancel again. Since they result in x both directions, we've proved that they are inverses of each other. So what we're trying to show is this. So if f of g of x is equal to g of f of x, which happens to be x, then f and g are inverses of each other. So that's how you prove it. So if one of them is not x, you would just say no, they're not inverses and stop. But they did want the output, so you'd have to do it here. Any questions on 12? Okay. These are just graph questions. Okay. Oops. For the graphical part, let's say at the beginning, let's go to the top. They said F and F inverse are reflections of each other over y equal x. So basically, if you draw a line through the middle and you reflect it, flip it over, or picture yourself folding the paper, that would be your inverse. So y equal to x y equal to x is right here. So picture yourself folding it over to the other side, reflecting it. That would be this guy, D. To reflect it over this. It's hard to picture in my head because I'm a little dyslexic, but y equal x is graphs to find the inverse y equal x. Reflect it. Yeah, there it is. I'm sorry. I chose B, right? Not D. Yeah. So reflect this guy over here. That was throwing me for a loop. I'm like, how the hell is it D? Anyway. So that's all you got to do. Do reflection. These are just easier than the first one. Just verify that they are indeed equal to x. They are inverses. They just want you to go through the work that we just did earlier. And then they ask for to graph them. That is the main idea. Make sense? Okay. All right, well, we'll stop lecture here. Do you guys have any questions about the homework, or are you struggling with anything overall? You can go over any topics you like. We got some time.